In some situations, a hydrocarbon chain will curl back around and close up to make a ring shape. And we're going to talk mostly about alkanes, at least at first. We use a line drawing to show these shapes, so they end up looking like a shape. If a propane chain folds up, you get a triangle. And this indicates, 1, 2, 3 carbons bonded with single bonds, and we would call it cyclopropane. If we have 4, looks like a square, and we say cyclobutane. We have 5, we have cyclopentane, and 6, I apologize for my unattractive drawings, but you get the idea. We have cyclohexane. So let's apply these to some examples. First, we have to find the longest chain, and hopefully that is the ring. And we can count. We want our functional groups to have the lowest numbers. And so we'll go 1, 2, 3, 4, 5, 6. I would, if you have this case where you could have 1 here or 1 here, and then they'd both be 1 and 3, I would pick the larger functional group or the largest chain to be 1. For this branch, you could say it was ethane with a methyl off of it, or you can say that this is isopropyl because it's a propyl chain that's connected in the middle. So it would become 1 isopropyl, three methyl, for this part, cyclohexane. This would be connected here, I just didn't have enough space, so it's not 2 words, you make it 1 long name. So no new rules, we're just saying that that hexane chain is a cyclical hydrocarbon. We just put 1 extra little prefix in there. Let's look at a second example. In this example, again, I'm going to put 1 at the longest chain, and then that's got to be 2, 3, 4. This is propyl, this is ethyl, and our ring is butane, or cyclobutane. We would name this in alphabetical order, right? 2 ethyl, 1 propyl, cyclobutane. In some occasions, the ring is not the longest chain. Let's look at an example like this. So in this condensed version, you can see we have a chain of 4 with a ring of 3. So the chain of 4 is longer. You can expand it if you'd like, if that makes it easier for you to see. You can see that this is butane and that this is cyclopropane. So because we're treating it as the functional group, we would say 1, 2, 2 cyclopropyl, and we'll add the ly because it's the functional group, butane. And we could make this as complicated as we wanted to, using all of these rules we're going to learn or have learned. but I wanted you to know it can be either the main chain or a substituted chain. We can even get as complicated as this. We can have two rings attached. This is the bigger ring, and that is cyclopentane, and this is cyclopropane. You don't really have to say one because it's the only thing off of it, and it's a cycle, a cyclical hydrocarbon. We would always say that that was number one. Wherever that is, that's number one carbon. So we would say cyclopropyl, though if you said one cyclopropyl, it would not be incorrect. It just isn't necessary. Cyclopropyl, cyclopentane. So hopefully you're feeling a little more comfortable with how you're using cyclic alkanes. With alkenes, it's a little bit different. We don't deal with them very much except for aromatics. Aromatics are based off of benzene. We haven't talked about it, but your book goes into extensive explanation about why those cyclical alkanes we just talked about aren't very stable. So they tend to open up and have reactions fairly quickly. But benzene is extremely stable in all aromatics because they're based off of this benzene, because it alternates double and single bonds. Just for the purposes of an explanation here. We know that each of these lines indicate shared electrons. What we find in aromatics is that these electrons move. So this shared pair can move here, which then means that this carbon now has too many bonds because there's a hydrogen out here. So this shared pair moves here, the same thing happens, and it moves there. This is called resonance. So when we draw that, we have to know that it's alternating all the time between that structure and this structure. And this is one of the principal ideas of organic chemistry. This moving electrons. We had a whole book about it when I took organic chemistry in college. And we would call it pushing electrons because those shared pairs would move. We're not going to talk about resonance structures very much except for right here. But I just want you to understand that that's why benzene and aromatics are so stable, because they have these moving electrons, so the bonds can shift and move for whatever state is the least energy, and it will stay there. So because we know it's both this and this at any given moment, what we will typically write for benzene is this, because those double bonds are shifting that whole time. When we are considering the benzene ring as the primary chain, then we call it benzene. When we are considering it as a functional or substituted group, we call it phenyl. And you can choose whichever way. Sometimes it's very obvious, like if there's this really, really long chain, and then there's a benzene on it, and there's a bunch of other things off this long chain, then the benzene has to be a substituted group naming-wise. It's just too complicated otherwise. But if there's a benzene ring and it's got one or two or three little substituted groups off of it, then you want the benzene to be the main group. So pick whichever naming convention is easiest there, if whichever one you want to be the primary. And as long as it makes sense, you'll be good. Let's look at two examples. For right now, we haven't yet covered all those functional groups, so I'm just continuing to use pieces of hydrocarbon chains. But once you learn the functional groups on the next page, they would work the same way. You would just use the special names we will cover for them. In this case, our benzene ring has to be the primary chain because it's got 2 substituted groups off of it. It doesn't really matter which way we number because there'll be 1 and 3. So I'll pick the larger group to be 1. And this would be 1 ethyl because alphabetically that's first. 3 methyl. Benzene. If you have an example that has just 1 functional group, you don't have to say the number because wherever that 1 is going to be carbon number 1. Remember, we arbitrarily named them. It's not so much about knowing like this is carbon number 1, but it's about knowing relationship between the end of like where these are located according to the end of the chain, according to other things. So this example here, if we took off that ethyl group, would just be methylbenzene. In this example, it looks to me fairly clear that we would want the chain to be our primary group. And we can break this out. We can expand it. I'm going to expand it here in this space. So we have 1, 2, 3, 4. And then we have a methyl, 6. And this has our benzene ring. This is going to be carbon 1 because it's closest to a functional group or a substituted group. It's a chain of 6, single bonded, so we know it's going to be hexane. It'll be, and this is phenyl and this is methyl. Methyl alphabetically comes first, so we would say 4-methyl, 2-phenyl, hexane.